Om Sri Sai Ram. From last 3 parts, now we have learned various uses of pointers with various other concepts of C++ programming. For example, we started use of pointers with the variable to print the address of variable by using a pointer, as well as to access the value which is stored at that particular address by using the pointer. Then we have seen how to access the array contents by using the pointers, and how it is easy to manipulate the array contents by using the pointers. In fact, we have discussed that the array name itself is a pointer to the first element of a array, and then we have extended the use of pointers with the strings. Now today we are going to work with the most complex feature, that is use of pointers with the functions. So as I told, hope all of you have revised your concepts of functions, and I expect that all of you are getting interest while working with the pointers. So today we will see the use of pointers along with the functions. So in the today's class we are going to learn pointers and functions. While working with pointers, we are going to learn 3 techniques. Number 1, call by value, that is calling a function by passing the value of a variable. This is the normal case, this is the normal way of calling a function that we have studied in the first PU itself. Then call by reference, this is the new thing that we are going to learn today. And the third mechanism is call by address, that is calling a function by passing the address of a variable. Then we will see the use of pointers with the structures. Hope all of you remember the concept of structures that we have studied in first PU. Structure is nothing but the same as that of the class. Only the difference is that we cannot define functions inside the structures. So to understand this concept very clearly, I again would like to appeal you that you revise your concepts of structures. And then we will see the use of pointers with the class objects. Just like the way we have created integer pointers, float pointer, character pointers, and then pointer to the array, same way we can create a class pointer also. Class object you know. So now class object is what? It is a variable of type class. Same way we are going to create a pointer of type class. So let us begin. So in C++ there are 2 ways to use pointers with functions. One is call by reference, another one is call by address. We can also call it like that, pass by reference or pass by address. So here this one important term we have to understand, that is reference. What is meant by reference, that we are going to study. First we will go back to our concept of call by value. First we will clear the concept of call by value. What is meant by call by value was once again we revise, so that it will be easy for us to understand call by reference as well as call by address. So let us see the mechanism in detail in this video, that what is call by value and what happens when we call a function by passing the value. So when a function is invoked, that means when a function is called, a correspondence is established between the formal and actual parameters. So here also now you are encountering the 2 terminologies, formal and actual parameters. Formal and actual parameters. So this also you have to revise the concept of functions. What is formal parameters and what is actual parameters? I will explain this in detail today. Just look at the next point is, a temporary storage is created where the value of actual parameter is stored. So when you are calling a function by passing a value, a temporary storage is created where the copy of the actual variable is stored in that location. Then the formal parameter picks up its value from the storage area. The formal parameter picks up the value from that storage area. Here I would like to give an example is that suppose I have created a notes of some concepts, C++ concepts. I want to give it to you students, right? So there are around in our class 42 students are there. So one copy cannot be shared, one hard copy cannot be shared by 42 students. So what I will do? I will create a copy, 42 copies of my original notes, and I will put it in library so that everybody can take all the 42 copies from that particular location. So this is the same concept with that. So original copy you are not accessing, you are accessing the copy of the actual content, copy of the actual notes. We will see this in detail. This mechanism of data transfer between the actual and formal parameter is called value parameters, and mechanism of data transfer is referred to as call by value. So we will see this mechanism with this example. Here we are going to write one program, simple program which makes use of a function. There is nothing new in this program. This is the simple program that we have studied in first PU class. Here I am going to write one function. The name of the function is fun. It is not returning value, that's why I have given the return type as void. And here I have declared one parameter. So this is our actually the what we call it as the formal parameter. This is called formal parameter. That means what is formal parameter? The variable name that we declare in the function header. This is called function header, that is called formal parameter. So here ptr is the formal parameter. Then in the function definition, what I am going to do simply, I am going to add the value 10 to the ptr, contents of ptr, and then I am going to print the contents of ptr. So this is the definition of this function. We will see what happens in the memory when we execute this function. But let us see in the main function how we are going to call this function. In main, what we will do? Simply I will create one variable a and assign the value 10 to the a, and then I am going to call this function fun by passing this variable. So this is also a parameter. Which is this parameter? This is the actual parameter. So ptr is the formal parameter and a is the actual parameter. Now I am going to print the value of a and I am closing the program. So this is our complete program. So let us see what is happening in the memory. So I am going to create a memory picture. Suppose this is a memory area of function fun, and here there is variable int ptr. So in ptr, in this function area, what I am doing? ptr is equal to ptr plus 10. So this instruction is there in this function. So what is happening? ptr is equal to ptr plus 10 means the contents of ptr now become 10 here. As per now, nothing is there in the ptr, so the contents of ptr will be 10. So when we print the contents of ptr, we expect that it will print, suppose this is our output screen, and to the output screen it will print 10. If we think this function as a standalone function. Now look at in the main, when this function will be executed, when we call the function. So in this main, what is going to happen in the memory area of main? This is the memory area of main. Here I am going to create one variable, say a, and I am assigning the value 10 in this memory area 10. So this is the memory picture, or we say memory representation for the function main. So what happens when I call the function a? This 10 value is going to be passed to this ptr. This is a PTR. So this 10 value, the copy of 10 gets created here, and this copy, this is a copy. So the copy of 10 will be passed to PTR, which is in the function fun, and then the function fun, this instruction is operating on that copy. So PTR is already what? 10 we have passed, and we are adding this 10 to the PTR. So 10 plus 10, 20. 10 plus 10, 20. So when you output PTR, it will print 20 on the output screen. Okay. This is the part of function. So once it outputs PTR, it will return back to the main function. So in main function, what we are going to do? We are printing the value of A. So you can see here, there is no change in the value of A. So when you output the value of A, what it will print? It will print 10. So A will print 10 and PTR will print 20. Because why? Because there is actually no connection between PTR and A once we pass the value to the PTR. So this fun will operate on the copy of this value. It will not operate on the original value of A. There is no change. So here comes in picture our mechanism of calling a function by reference. So here you have understood that when we call a function by value, the function, the called function, okay, this is also one more terminology. This is a called function. If you remember, this is a called function. And which is the calling function? This main. This main is a calling function. So these terminologies also you must recall. And this is what? This is the formal parameter. This we call it as formal parameter. And which is the actual? So this A which is passing to the function, this is the actual parameter P. I am writing just short. So this is actual parameter, this is formal parameter, and this fun is a called function. And who is calling this function? Main function. So here main is the calling function. So these terminologies you must remember. So here there is nothing special happening. We have wrote one function which is operating on the copy of the function. Our task is that we should be able to change the contents of actual parameter, the contents of actual variable which are there in the calling function. That is our today's task. So let's see how we can achieve this. We can achieve this with the call by reference mechanism. So what is call by reference mechanism? Before going to understand the call by reference mechanism, we must understand what is meant by a reference. That, if you remember, we have discussed in the first PU class itself, as well as in the beginning also I have told you and with the example that what is meant by reference, but let us revise here. First understand what is reference parameter. Parameter, you understand? What is parameter? That something we use while calling a function. When we pass something or in the function header, that we call it as a parameter, or you can call it as a argument. So a variable which appears in a function heading. Okay, what is function heading? Again you might be confusing here. What is function heading? Function heading means is a simple thing. So when you declare a function, say here take an example of a previous function where I wrote this void fun and then int ptr. So simple, this is a function header where we can just write the return type, name of the function, data type of the parameter and the parameter name. So the name which appears, a variable which appears in the function heading, this is a function header, that we call it as a reference parameter, but which has exactly the same data type as the parameter. The parameter which we are passing from the calling function. So this data type and the actual parameters data type should be same, that we call it as a reference parameter. How to create this reference parameter? that we will see. Then what is a reference variable? A reference variable is one that you declare by attaching a reference operator. This is a reference operator, ampersand operator, to the name of its data type. In short, this reference variable is nothing but the alias to the actual variable name, or you can call it as the dummy name or alternate name. What is the need of this? Suppose I will give an example. A person named Venkatesh, whose name is Venkatesh, but his family members or his friends will call it as a Venki by lovingly or just to calling it easily. But here the Venkatesh and Venki refer to the same person. So here Venki is a reference to the actual name Venkatesh. Venki is the alias to the actual name Venkatesh, but both the alias name, that is the alternate name, as well as the actual name, both are referring to the same object, that is person Venkatesh. So same here, reference variable is nothing but the alternate name, or we call it as the alias for the actual variable name. How to create it, that I will teach you here. So a mechanism also given, it is attached, it is prefixed with the ampersand sign and the data type. So it is called reference parameter because the called function can refer to the corresponding argument directly. What is the need of creating reference parameter or reference variable? So that the called function can refer to the corresponding argument directly. We want to directly call, or we want to directly refer to the actual parameter. So let's see how to create the reference variable here. Suppose I am creating one variable, say total. Here float total. This is one actual variable I am creating and I am assigning the value 100 to it. This is the actual variable. So what is the syntax for creating a reference variable? The syntax is, as it is defined in the previous slide, that it must be followed by, it must be preceded by the data type. Data type is float and then ampersand sign and then reference name and then here you have to give the actual variable name to which you want to create a reference name. This is the syntax. For example, I want to create a reference name sum for total. So how I will create? Float reference operator, then alias name, alias sum, and then I will write the actual variable name total. So here we have created a reference name sum for total. So here sum is the reference name. I will write it. Sum is the reference name and total is the variable name. So what is happening in the memory? Let's see here. We have created one variable. This is the memory location. To this memory location we have given the name total, which is the actual variable name. And then in this variable, in this memory location, we have inserted the contents 100. Now we are creating another name sum. So here sum is another variable name. It is a name, but it is also referring to the same memory location sum. So both are referring to the same memory location. So this is the way you can create the reference name. So how it behaves? Let's understand here. The value of total is 100 here. So when I output the value of total, like cout total, it will print 100. And when I will output the sum, it will also output 100 because both are referring to the same memory location. So both the variables fetching the contents from the same memory location. So one point here is that as both are referring to the same memory location, if I am making the changes to the memory location, the contents of the memory location by using one variable. Suppose in 100 here I am adding 10. Suppose I am writing here total is equal to total plus 10, and again if I output the contents of total, what it will print? 110. And again if I print the contents of sum, so sum also here will print 110 because the actual contents are getting changed here. And suppose I do some manipulation on the sum. Suppose I am assigning sum is equal to 0 here. Then if I output the sum, it will print 0, and again if I output the total, it will print 0 because the actual contents I am changing with the help of the sum. So this indicates that both the variables, the actual variable and the reference variable, pointing to the same memory location. So one point to remember here is that when you create a reference variable here, it has to be initialized with the actual variable while declaration itself. It will not happen like this, that you are creating the reference, you are declaring the reference variable here, say float address of sum, and then you are initializing sum is equal to total. This is wrong. You have to initialize the reference variable with the actual variable while declaration itself. Hope you have understood what is variable, reference variable. Now let's make use of this reference variable in the call by reference mechanism. So when a function is invoked using a reference parameter, so now you understood what is the reference parameter. It is the location, that is memory address of the argument, not its value, that is passed to the function. What does this mean? When you call a function by passing a variable, then the copy of the contents of that variable will not be passed. Then what will be passed? The location, that is memory address, will be passed to the called function. Got it? Now next step is there is only one copy of the information and it is used by both the calling function and the called function. Again take the example of our fun, right? So fun will operate on the same memory location as well as the main function will operate on the same memory location. So when a function is called, the variable name, that is actual variable name here, as per our previous example, total was the actual variable name, and the reference name, that is sum was the actual reference name as per our previous example. Both point to the same memory location, and any change in the value of reference also changes the value of variable that we have seen. Now let's make use of this. Let's implement this procedure with the help of a program. This is a program. Here declaration is mandatory, declaration of a prototype. So this is terminology, this terminology also you should recall. This is called prototype. What we call this declaration as prototype. In general terms you can call it as a model of a function, that what kind of value it is going to return, then what is the name of a function, what is the parameter data type, and what should be the parameter. So here as we are going to create a reference parameter, that's why I have given the reference operator. So there is no need of giving the name here. In the prototype, the name of the variable, giving the name of the variable is not mandatory. So it is here only we have declared the reference parameter. And then in a main function I have created one integer variable number and assigned the value 4 to the number. Now I am going to print the value of this number simply. Now as I printed the value, you can see the value is printed here. The output of this statement is here 4. As we have assigned the 4, the value is printed here. Now I am invoking the function data double. This function I am invoking by passing the actual variable. And then again I am printing the value of a number. But this time what value it is printing? It is printing 8. Rather than 4, it is printing 8. Means there is some change occurred in the actual value of a variable. How this is occurred? Let's see the definition of the data double function. So here now I have, it is mandatory to give the reference variable name. Here there is no need of giving the reference variable name, but while defining a function you have to give the reference variable name. So what name I can give? I can give any variable name, no problem, but that should be meaningful, that should indicate the contents of the memory. So here I am giving the reference variable name as NUM, but one thing you must remember, the data type of the variable name, reference variable name, must be same as that of the data type of the actual variable name. Now in the function definition, I have written a simple arithmetic expression. What is num is equal to num plus num plus num. That's all. So what I am going to do here, I am adding the contents of num to its content only. So what is the, here when you call this function, what we have passed the value of a number. So value of a number it is passed, but actual value of number is not passed, right? We have passed the reference of a number. As num is a reference to a number, we got the memory address. So what this function does? This function goes to that memory location and fetches the contents of the number, and we are adding 4 plus 4, 8. Okay. So then after calling this function, when we print the value of number, it is printing the updated value, that is 8. Hope you understood this program. So let's see the memory picture of this program. What's happening in the memory? See, this is the memory area of main. In main, we have created one integer variable number. This is the memory location. In this memory location, we have assigned 4 to the number. That means 4 is stored at this location. Okay. And in data double function, what we have done? There is a num. This parameter is a num. Okay. So this num, as it is a reference name to the number, it is referring to the same memory location here. So it is referring to the 4. And in this expression, num is equal to num plus num. That means what? It is fetching the contents of this number, that is 4 plus 4. So 4 plus 4, it will update the contents 8. So where this 8 will go? This 8 will replace the contents of 4, contents of number. So 4 will be replaced by 8. This is how the call by reference mechanism works. Hope you understood. So let's move on to the next mechanism. That is, before going to the next mechanism, let's understand the advantages of call by reference. Why we need this technique? 1. Since arguments are not copied into new variables, here we are not going to create new variables. We are not creating new variable. We are not reserving any space for num. So question of copying the arguments in the new variable doesn't arise. So what is the benefit of that? It provides better time and space efficiency. See, when you create new variables in the memory, it consumes time. For creating a memory location, for reserving the memory location, compiler has to find the free space in the memory. That requires a time. And as you are creating a memory, that means you are consuming the memory also. The time and space, both the things you are consuming here. But as you are not creating any memory space, so time we are saving as well as the memory space also we are saving. Here I would like to give one example. Take an example of my notes. I have created notes. These are the printed notes, and I have given those notes for the editor, for the subject expert to correct it, to verify it. So I have two ways. One thing, I can tell him that you take my notes and make the corrections on the notes itself. So what will happen? He will take it, my notes, and he will verify and mark the correction on the notes itself and return the same copy to me. Right? Another way is that I will make the Xerox copy of my notes. Right? So for making a Xerox copy, two things I have to do. One thing is time. I have to give the time. I have to go to the Xerox machine center, and then I have to make a Xerox. So lot of time will be consumed, and I have to pay the money also. So two things I am losing here, time as well as money. And third resource is the paper. Paper also I am utilizing. And then I am giving it to the moderator or the editor, and then he will make the corrections on the copy, Xerox copy, and then he will return the Xerox copy to me, and I have to make the changes. I have to update the changes from Xerox copy to my original copy. So there is a lot of time, money and space. Here paper is the space. Everything we are losing. But it is easy when I allow the editor to make the changes on the original copy. Got it? Of course, there is a drawback also. If I am giving the original copy to edit, I will not have anything with me. So it may happen if a editor is not handling the original notes properly, suppose it gets turned out, or if he makes the changes unknowingly to the some part of the notes, right? So then I will not have a original copy. This is also a drawback. Same is the case with the programming also. If you are calling a function by passing the reference, so there is a 100% danger that original contents may get spoiled. So while working with the call by reference mechanism, the programmer has to be more cautious. Now the next point is, the function can change the value of argument and the change is reflected in the calling function. Here calling function is the main function. So when whatever changes you are making in the arguments, that will be reflected in the calling function. So a function can return only one value. With call by reference we can return multiple values. Yes, we have seen a function there is only one return statement in a function, but with call by reference we can return multiple values, because we can create multiple aliases for the original variables, actual variables in the calling function. One example I would like to give here for this. That example is, here previously we have created only one function, say void, it is not returning anything, and the function is here. So how you can create multiple references? Int, say ampersand, here I am writing a1, and int ampersand a2. This is the function header. So references to two variables of the calling function I am creating here. So in the main, what I will do here, in the main, the original variables are, say, int x and int y, two variables. So when I call a function fun, I am calling the function fun here, I am passing x and y. So what is happening here actually? The reference of x and y I am passing to the function a1 and a2. So when this function will execute, what it is doing? It is returning two values. We say that it is returning two values. So the function here returning two values, multiple values. So you can return as much as values by using the call by reference mechanism. So let's see the programming example, our favorite programming example of swapping the contents of two variables by using the call by reference mechanism. So this is the swap function where we have created two references x and y, and in the main function we have created variables a and b, and we are asking to input the values of a and b. So before swapping the values, that means before calling the swap function, we are printing the actual values of a and b. So the actual values of a and b here, when we entered here 56 and 23, that is the value of a is 56, the value of b is 23. And then we have called the function swap. While calling a function swap, we are simply passing the variables a and b here, and then after calling the function, we are again printing the contents of a and b. So you can see the contents of a is 23 and the content of b is 56. That means the actual contents are changed here. So look at the function swap. What we have done here? We have created two references. X is a reference to a and y is a reference to b. And in this function we have created one temporary variable which is local to the function swap. Now with the help of this temporary variable, we are interchanging the contents of x and y. How we are doing? We are assigning the value of x to temp, and then we are assigning the contents of y to x, and then we are again putting the contents of temp into the y. So this way, so it is actually what is happening here, we are interchanging the contents of a and b. So I will demonstrate you this scenario with the pictorial representation of the memory. So here a is created in the memory and b is created in the memory. These are the actual variables. So initially we entered 56 for a and 23 for b. So when we pass the references of x and y, what is happening? This x is referring to a and y is referring to b. So here we must take care that the data types of the reference variables should be same as that of the actual variables, and the sequence also we must take care that the sequence of the variable declaration, the reference declaration should be same as that of the passing the variables to the function. So in the swap area, what we have called, this is the memory area of swap. So in this we have created one temporary variable temp. So initially what we are doing, temp is equal to x, that means actually a, here x and y referring to a and b. So temp is equal to x means these contents we are putting in temp, so the value of temp is 56, and then we are saying x is equal to y. So x is equal to y, it is equivalent to a is equal to b. So a is equal to b means what? We are copying the contents of b into a, that is a will get replaced by 23, and then y is equal to temp. Y is equal to temp means what? Actually b is equal to temp. Y is equal to temp means b is equal to, so instead of y you can consider here it is b is equal to temp. Means what is happening? The contents of temp which we have copied from a, we are storing in b. So this will be replaced with the 56. So when you again print the value, so what has happened here? The actual contents of a and b gets interchanged. So when you again print the value of a and b, you will see the contents of a and b are interchanged. Hope you have understood this example, and let's move on to the next technique, that is call by address. So here in this call by address, we are not creating references. So here definitely there is a time and space consumption is there. So here is the actual use of pointers with the functions. In this type of function call, instead of passing values, addresses of actual parameters are passed to the function. We know that each variable is having the address associated with it. So we are passing the address of a variable, actual variable, to the formal arguments, that is the function arguments. So the formal parameters must be declared as pointers. We know that who is able to store the address? The pointer. Pointer is able to store the address of another variable of its type. So in the formal parameters, instead of declaring the variable or instead of declaring references, what we are going to declare? We are declaring the pointers. So pointers will be the formal arguments here. So the address of the actual arguments are copied onto the formal arguments. The values that are altered or changed within the called function, which is the called function, the function which you are going to call, are reflected into the calling portion of a program. Generally we have seen the example that we are calling the other functions in the main function. So main is the calling program or calling function, and the other function, that is the called function. So whatever changes are happening in the called function, that will be reflected in a calling function. Hence the changes made in the argument are permanent. So whatever changes are happening in the called program or called function, that will be permanent in the main function. Now let's take a task that we want to change the value of a. Very simple task to change the value of a. A is the actual variable. So what we will do here, the function we will write like this: data type, return data type, name of the function, and as we have seen in the previous slide, the argument will be the pointer. Formal argument will be a pointer. And in this, what we are going to do, we are just simply adding the contents of 10 with the pointer. But we have to see that to which this pointer is pointing to, right? So that we will see in the main function. So in the main function, we have created one variable a and assigned the value 10 to a. And then next we are calling the function. So here you have to check, while calling a function, what we are doing, we are passing the address. So instead of writing this function like this, fun and a, so here we are actually passing only the variable. We have added one more, that is the reference operator. So here address we are passing to the function, and then we are printing the value of a. Let's see what is happening in the memory here. See, in main we have created a and assigned the value 10 to a. So this a is associated with some address. Say address is say x0 f e d c, like this. This is the hexadecimal address of a. Now this is the main function, user defined function. So here we have created one pointer variable ptr. This is the pointer variable, and it is also having some address x0 f e suppose dc4, like that. Some address is there, that is of nothing to worry about that. And then when we call this function fun address of a, what is the address of a? x0 fee dc. So this address we are passing here, x0 fee dc. This address we are passing here. So as the pointer gets the address, right, what it will happen, we know that when a pointer, we assign the address to the pointer points to that memory location. That means the pointer is able to access the contents of this memory. Then here dereferencing operator. This dereferencing operator is what? It is dereferencing this address. Dereferencing this address means what? It is accessing the value stored at this address. So 10 it is accessing. So how it is accessing? 10. So 10 plus 10, 20, and again this 20 it is replacing to the original contents. So 20 will be stored at a. So when you print the contents of a, you will see that the contents of a will be 20. So the actual value of the actual variable, that is the variable in the calling function, gets replaced and the changes are permanent. Now this is with the single variable, modification of the value with the single variable. The same functionality we can extend for the arrays also. So let's see an example of modifying the contents of array with the help of the function and passing the address of the array to the function. So what is our task? We want to divide the contents of array by 10. What are, this is an array. I have declared an array A with 5 elements. These are the contents 10, 20, 30, 40, 50. Okay. Let's draw the memory picture of this array. At the end we will draw here. And then what I have done, so these are the 1, 2, 3, 4, 5. So 10, 20, 30, 40 and 50. So this is the array. Now original contents of the array I am going to print A of A. So A of A is printed here. See 10, 20, 30, 40, 50. It is printed here. Now I am calling a function sum A. What I am doing here? I am passing the name of the array. If you remember from the previous lecture, the name of array is the pointer to the first memory location of the array. So here A is having the address. Say consider the address of this these memory locations are like this, say x01, x02, x03, x04 and x05. These are the addresses of these memory locations in an array. So as A is holding the first address x01, so this x01 address I am passing to the function sum. Address of first memory location we are passing to the function sum. So come to the function sum. It is same as that address of A of 0 because A holds the address of first memory location. And what we call it as, if you remember, we call it as constant pointer. A is a constant pointer. It is not a pointer variable. So we cannot change the address of A. This is constant pointer. The space constraints are there. Okay. So it is a constant pointer. It is same as that of address of A of 0. So this clearly tells us that A is what? It is address of A of 0. So come to the sum function. Here to receive the address we have declared the pointer variable as a parameter, formal parameter. Now by using the for loop, what we are doing? The for loop is executing from 0 to 4. I less than 5 means it will execute from 0 to 4. So 5 cycles it will make. And what we are doing? Star ptr is equal to star ptr by 10. What is star ptr? It is dereferencing the array contents. So star ptr, the first address it is received is the address of 0th memory location, that is 10. So 10 by 10 will be 1. So it will return 1 here. So it will replace the 10 by 1 by dividing 10 by 10 1. And here we are performing the arithmetics. Ptr is equal to ptr plus 1. Here ptr is the pointer variable, it is not pointer constant. So we can move it, we can perform the arithmetics with the ptr. So we know when we write, what is the meaning of this statement? Statement is we are moving the pointer one more memory location ahead. So initially ptr is pointing to the first memory location, right, and adding 1. Adding 1 means moving the number of bytes allocated to one memory location in an array. So how many bytes are allocated here? That depends on the compiler. If it is a 4-bit 32-bit compiler, then one integer data value consuming 4 bytes. So it is moving 4 bytes. In simple terms we can say that it is moving on to the next integer location. So ptr will come here. And then again it will perform star ptr is equal to star ptr by 10. So here contents are 20. So 20 by 10 will be 2. So it will replace with 2. So the contents are changing here. Same will be happen with the third when pointer comes here, then fourth and then fifth. So the actual contents we have changed here by passing the address of the array or address of the first element of the array. This is the most efficient use of the pointer while manipulating the arrays. And you can see again we are printing the contents of array. When we are printing the contents of array, it is giving the modified contents 1, 2, 3, 4, 5. That means the actual contents are changed with the help of the function same. So here the function sum is called by passing the address of the array. This is the pass by address mechanism. Let's see one more example. It is a simple example, same that the first example we have seen, little bit of change. But the more and more examples we will see, the more and more concepts will be clear to you. So here the same function we have declared int data double, here the dereferencing operator, not the ampersand, because here we are creating the pointer, not the reference. And then one integer variable assigned the value 4 and we are printing the contents of number. So it is printing 4 and then we are calling the function. While calling the function we are passing the address. It is the address of number. And then we are printing the new value of number. So the new value of number is 8 because here in this function what we have done, num plus num, dereferencing num plus dereferencing num. So it is accessing the contents. Let's see the memory picture of here. What is happening here? As we are calling a function, this num is referring to the number. This address we got actually, this address we got, this 17,500, it is not actual address, this address is copied here. So what is happening then? This num is a pointer which is pointing to this memory location, and then star num, that is this value, will be accessed by the dereferencing operator. So 4 plus 4, 4 plus 4, 8. So you can see here this 8 will be again copied onto the original memory location. So this is the memory picture of the main function before the call of this data double function, and after the function call, this is the memory picture. Hope you have understood this call by address mechanism. So now we will see our favorite example of the swap function by using the pass by address mechanism. So here in the swap function we are creating two pointers as formal parameters, int star, int star. So this is the prototype, and here we are creating two variables int a and b and providing the contents to the a and b. So 192 goes to a and 67 goes to b, and before swapping the function we are printing the values of a and b. So you can see a is equal to 192 and b is equal to 67. Now we are calling the swap function. So here we are passing the addresses of two variables a and b, and then come to the function here. The value of a, the address of a will be received by x, the address of b will be received by y, and same way we have created the temp variable. With the help of the temp variable we are changing the contents of x and y. So the x means which is referring to a, so the value of a will go to temp, and the value of b, y go to x, that is y is having the address of b. So the value of b will be assigned to a, and again the contents of temp, where we have copied the contents of a into temp, that is going to y. So here actually we are swapping the contents of a and b. So when we print the values of a and b after swapping the function, after calling the swap function, you can see here the contents of a and b are swapped. So if you understood the previous program, pass by reference, then this is also same. What is the change here only? Here you have to use the address of operator, and instead of creating the references you have to create the pointer variables, and here also you have to make use of the dereferencing operator. Otherwise the things are same, but internally the things are different. Why? Because here in function swap we are creating the memory for x and y as well as temp, and then we are passing the address. Contents we are not passing, but the addresses we are passing. So that advantage we don't have here. Which advantage? That saving the time and the space. time and space efficiency, that advantage is not here, but major advantage is here is that we can directly access the contents of A and B, contents of actual variables. So if you understood the use of pointers with the functions, so now our next move is use of pointers to access the structure members. So here you have to recall your concepts of structures, but nobody, this example will give a brief idea how to create a structure. So in short, I would like to tell you that structure concept is introduced in C programming language to overcome the limitations of arrays. What is the limitation of array? That in array we can store the elements, data elements of same type. We cannot store the data elements of different types. But with the help of structures, we can store the data elements of different types. So the structure and the pointers, by using the structures and pointers, we can create complex applications or complex databases with the help of the data structures like linked list, stacks, queues, binary trees and graphs. This is the main advantage of pointers with structures. So this is the syntax of the structure. Struct structure name, then data type 1 member name 1, data type 2 member name 2 and other members. And here after closing brace we can create a structure pointer star strptr var. This is one way of creating a structure pointer. So we call it as structure variable. We call it as structure variable. So now instead of structure variable we are creating structure pointer. Structure pointer. Or this is the another way to create the structure pointer. Struct keyword, name of the structure and the structure pointer name. Either way you can use it. No issues. Now example is we are creating the struct date. So date is a user defined name. Struct is a keyword. This is a keyword. And this is user defined name. So in this struct date we are creating 3 integer members, day, month and year and semicolon. Now we are creating the structure pointer struct date star pdob. So here pdob is a pointer variable holding the address of the structure date and is having 3 members such as day, month and year. This is the definition of this particular syntax. Now there are 2 methods to access the members of the structures. Method 1 is by using the dereferencing operator. Star strptr var, it is a structure pointer name dot member name. So here bracket is very important, parenthesis is very essential because structure member period, this operator has a higher precedence over the indirection. That's why it has to be, this pointer has to be accessed first. That's why this bracket is essential here. For example, star pdob dot day will access the day member of the date structure. Another method is by using the arrow operator. So this method is more preferable over this method. Structure pointer name, arrow operator, that is dash sign and the greater than sign, and the structure member name. So in our case, what are the different structure member names? Day, month and year. So you can access any structure member with this arrow operator and the structure. So this operator is known as the pointing to operator. Which one? Dash and the greater than sign. Or simply you can say it as a arrow operator. So let's see and program. Here is our structure date having 3 data members, day, month and year, and in the main we have created the struct date dob. So what we have created? We have created the structure variable here first, and then we have created the structure pointer. It is same as that of we create the integer variable int I, and then we declare integer pointer star I ptr. It is same as that of. There is nothing new. Only here instead of int we are using the date structure, and then we assign the ptr is equal to address of dob. In the same way that we use I is equal to, IPTR is equal to address of I. So it is same. These three statements are equivalent to this. Instead of int data type, which is a primitive data type, we are using our user defined data type, that is struct date. So this keyword is essential here. Struct keyword, you have to precede the user defined name. Then we are asking to input the valid date parameters. So to input the valid date parameter means we have to assign the value to day, month and year. So we have to access day, month and year. So we are accessing with the arrow operator, PTR day, PTR month and PTR year. In place of this code, you can use this code also, dereferencing operator, star PTR dot day, star PTR dot month, star PTR dot year. So both the code is equivalent, but this code is preferable over this code. And then we are printing the contents of the structure members, day, month and year. So day, PTR and month. So here I have formatted the date with the slash sign. So I have entered the today's date 24/5/2020 and printing the date. So it is very simple. The part to understand here, how to create the structure pointer, how to assign the address of the structure pointer, and then how to access the structure members by using the structure pointer. This is very simple. Now move on to pointers and class objects. If you understood the structures and pointers very well, then objects, class objects and the pointers or pointer to the object is very simple. So pointers can point to objects as well as simple data types and arrays. So this is the syntax. Here we have created the class student having registration number, name array and the marks. And two member functions we have declared here, and what we are doing, creating the pointer to the object star pstdobj. Let's see an example. Again same, the methods which we have used for accessing the members of the structure, the same methods are here, same thing. Just here instead of the structure, here we have to use the object name, structure pointer to the object. In the same way we can access. And this is an example program. Here we are creating three data members, two are the integer variables, one is the character array, and here we are entering the values of registration number, name and marks, and we are displaying the values. Very simple way. This is the class, definition of a class, and in main function we are creating the pointer to the structure student. So student star pstdobj. So one difference you have to note here is that while creating the pointer to the structure, we have used the keyword struct. Here you don't have to use the keyword class or anything else. The way we create the class object, class name and object name, same way we are going to create the class pointer. What? Class name and the pointer name. And then we are accessing the two functions, display read data and display data. This is the read data function and display data function. So it is very easy as compared to the structures, and we are here printing the contents of the class members. So hope you have understood all these concepts very well. Today's lecture was the bit complex to you, but it is very interesting to work with the pointers. If you are able to work with the pointers, then you can do anything. Your programming logic will be improved because more focus is required. And as pointers we are using with simple variable, we are using with the arrays, then we are using with the functions, we are using with the structures, and we are using with the classes. So variable, arrays, functions, structures and classes, these are the basic concepts of object oriented programming that you must have clear in your mind. If you have very much clear in mind, then we can work efficiently with the pointers and apply the concept of pointer on these basic concepts. Hope all of you understand this class very well. I recommend you that you execute all these programs, try your level and execute the programs which are given in the textbook, and for any clarification you can get back to me. Thank you. Sai Ram.